Literature survey. Since the thrust of the present work is on the spectroscopic studies of the diatomic barium oxide BaO, the survey of this molecule is done in detail. The secondary diatomic alkaline earth oxides are also discussed as a general group, especially for the work on potential energy curves, dissociation energies, reduced potential energy curves, etc. Mahanti measured the bands of BO between 12,000 to 23,000 per centimeter in 1934. The high resolution spectrum of BO resulting from the transition A signet sigma to X signet sigma falling in the region 14,000 to 20,000 per centimeter was studied by Lagerquist in 1950. They corrected the rotational analysis of Mahanti and analyzed 11 bands, 11 bands. Excitation of BaO was done by feeding BaCl2 in an acetylene air flame. In 1963, Watson and Klemperer detected pure rotational transition J is equal to 1 to J is equal to 0. They used the molecular beam electronic resonance method. Timon measured the microwave absorption spectrum of ground state employing a high temperature oven. Field studied the microwave optical resonance spectra of both X and A states using a Broider type oven. Hawking obtained the millimeter range spectra of CaO, SRO, and BaO in 1992. Bloom performed new microwave measurements using laser ablation, and a recent set of Denham coefficients is given for the ground states of all these molecules. In 1990s, Hettich and Bloom observed the first high-resolution infrared spectrum between 641 and 701 per centimeter using tunable diode laser spectrometer and a Broider oven source. Field has measured optical double resonance photoluminescence photoprogressions using two continuous waves lasers to excite BaO to 38,000 per centimeter above ground state. All these studies were of ground state X signet sigma. Spectroscopic studies of the A signet sigma state of BaO were also carried out by studying the excitation via exothermic reactions such as Ba plus N2O and Ba plus O3. These reactions played an important role in producing the visible and ultraviolet chemiluminescence. In the presence of argon gas at the pressures 0.01 to 0.02 torr, the AX bands become stronger and dominate the spectrum. The bands of A singlet to X system in a region 23,000 to 30,000 per centimeter were also observed by Su. Weiss and Broida carried out the vibrational analysis of the A singlet sigma to X to the ground transition using O16 and O18 isotopomers in BaO. They used the DC arc between the barium electrodes in the oxygen atmosphere. Kolmar studied B singlet sigma to X singlet sigma transition and rotationally analyzed the 06, 07 and 08 bands. The laser excitation of overlapping AX and A singlet X systems of BaO was produced by Prut and Jarre using Ba plus Cl2 mixture and a tunable pulsed dye laser. The weak long life A singlet to X fluorescence was separated from the strong short lifetime 356 nanoseconds fluorescence by delaying the observation of A singlet to X fluorescence until A to X system's emission has decayed away. All these workers that observed strong perturbations in the A singlet sigma state. Therefore, the analysis of A to X system was a challenging one. Recently, an excellent work of BO between the regions 8900 to 21,000 per centimeter using Fourier transform spectrometer at a resolution of 0.04 per centimeter is reported by Hongzhi Li. The chemiluminescence of BaO was excited by the reaction of Ba with N2O in a Broida type oven. Hongzhi have measured over 15,500 rotational vibrational lines from the four isotopomers involving V double dash up to 20 and V singlet up to 1120 and V singlet to up to V doublet up to 20 and V singlet up to 11. The details are given in this is in an up to date historical review of the BaO. The energy level diagram of BaO. Recently, the MgO molecule was studied by Eriko Kage, in which they have analyzed the A singlet pi to X singlet sigma system using the Fourier transform spectroscopy. Kage analyzed 10, 20, 21, and 01 bands of the system of MgO.